Dear students, in this video, I'm going to start the subject numerical analysis. The code of this subject is MAC 404. MAC 404, and I have already sent the syllabus on my Google Classroom. So you can find the detailed syllabus, but for the time being here I am giving the syllabus. So here we have total 5 units in this course. First unit is this, which is just the introduction, and I think you have already aware about this, the topics which will be covered in this. Here we will study about the revisit of root finding methods in this for non-linear equations and their order of convergence. Here we will discuss about the bisection method, the regular falsi method, the secant method, Newton-Raphson method, etc., and their rate of convergence. And then we will take few examples. In the second unit here we have system of non-linear equations, and here we have single equation, but in the second one we are having system, that means more than one equations. Okay, so this is the extension of the first unit. Here we have methods like Newton's method, quasi-Newton method, Broyden method. So we have these, and then we have applications. These are the engineering applications. These are applications coupled reversible chemical reaction, flow distribution in a pipe flow method, etc. So these are just the engineering applications. So we will take few examples. Then the third unit is based on the interpolation. Here we are having piecewise interpolation, cubic spline interpolation, Hermite interpolation, Hermite cubic interpolation. So here we will not discuss about the forward difference, backward difference. You have already aware about this. This is the extension of that, basically the basic concepts of interpolation. Okay. In the next unit we are having initial value problems. Here we will discuss about the Euler's method, higher order Taylor's method, Runge-Kutta method, multi-step methods such as Adam-Bashforth and Adams-Moulton method, and then their stability, convergence and stability. And then we will take some examples. In the last unit we are having 2-point boundary value problem. Here we have initial value problems, here we have boundary value problems. Okay, and the methods are finite difference methods for nonlinear problems with Dirichlet as well as non-Dirichlet boundary conditions, finite difference methods for nonlinear problems with Dirichlet as well as non-Dirichlet boundary conditions. Okay, here we have linear, this is for non-linear. Okay, so this is the difference. And then again we will take few examples. So this is the strategy, and if classes will open, then definitely we will try to give you idea about the coding. Coding means MATLAB. So we will try to make few programs, computer programs for these techniques. We will take few methods from first unit and try to make their code. Then we will try to take few methods from the second unit, few methods from the third unit, few methods from the fourth unit, and few methods from the last unit, so that you have some idea about the computer programming, how to code these problems with the help of MATLAB or any other software, and then how we can solve the problems. Fine, so this is the idea. So now we will start and as far as the books are concerned, books are already listed in the syllabus, you can see, but for the time being here we will use two books. One is this book, Numerical Methods for Scientific and Engineering Computation, and the author is M.K. Jain, S.R.K. Iyengar and R.K. Jain. Very good book. And the publication is New Age International Publishers. Okay. So this is one book. Second book is this Chapra and Kenel. This is numerical. This is numerical methods for engineers by Stephen C. Chapra, Raymond P. Kenel, and the publication is McGraw-Hill. This is the McGraw-Hill education. Okay, so you can also find out the soft copy of this book on the Google. So I think these are the sufficient books to cover up these, because in this, if you have seen that we are having engineering applications also, that's why we have taken this book to cover up this. And second thing is this Chapra book having some computer programs also, so this will also help you to have some idea about the computer programming. Okay, otherwise there are lots of books available on Google, you can find out those books. So now we will start the first unit. So root finding techniques. Okay, so here in this root finding techniques, what is the problem? What is our actual problem? Our problem is, aim is to find the solution of the equation 1, which is this f of x is equals to 0. Here f of x is a very, you can say that a complex equation, very complex equation, very highly non-linear problem. We will see the examples also. Okay, so now aim is to find out the root of this problem, because if f of x is a very simple equation, then you can easily find out the solution manually with the hand calculation. But if f of x is non-linear, then this is very difficult to find out the solution with the help of hand calculation. Then in general we need numerical methods. Okay, or we can use computer programming. So our target is to find out the root of this problem. That means find out the what is x. Now here f of x may be divided into broadly into two parts. One is explicitly or implicitly. What is meaning of explicitly or implicitly? Let's see. Explicit means what? Explicit means if f of x is a polynomial. So if f of x is a polynomial of degree say n in x, then f of x can be written as this. F of x is a naught xn plus a1 x raised to the power n minus 1 plus a2 x raised to the power n minus 2 and so on plus an. So this is a polynomial, and obviously since the degree of this polynomial is n, so essentially a naught should be non-zero, otherwise its degree will be n minus 1. So that's why a naught should be a non-zero quantity. So that's why this is the additional condition. Okay, so if, but this may be possible that f of x is not a polynomial, then that type of f of x is known as implicitly. So implicit. In this category we are trying to write this basically in implicit we are having different type of functions, but here this is also known as transcendental function, or this equation is known as transcendental equation. Okay, so here transcendental means this is the mixture of, so this, that means what is the meaning of transcendental actually? Transcendental means this is the mixture of polynomial, exponential function, trigonometric function, logarithmic function, etc. So whenever we are having mixture of these functions, then this function is known as transcendental function and the corresponding equation is known as transcendental equation. Okay, so here f of x may be this kind, cos x minus x e raised to the power x. So you can see that this is not a polynomial like this. This is a mixture of cos x, polynomial and exponential function. Okay, so this is transcendental function. So now how to solve this type of, so we will discuss about the methods. Now as far as the what is the meaning of root, here we are saying that this is the root finding technique. So what is the meaning of a root? So a number xi is a solution of equation number 1 if f of xi is equivalent to 0. That means both the sides will be 0 to 0. In the left hand side we will get 0. Then that is exactly satisfied. That's why this is equivalent to 0. So we are trying to find out those values of xi for which we are having left hand side itself 0. Okay, and such a solution xi is a root of f of x is equal to 0. तो जो भी इसको satisfy करेगा, we are trying to find out that xi. Now graphically is what? Graphically is this. This is your function f of x. What is our target? Our target is to find out that those values of x for which f of x is 0. So this is f of x. So f of x is 0 means this function intersects x-axis at which point? So our target is to find out that point xi. So f of xi here, this will be obviously 0. So this xi is basically the root. And here you will see that this function intersects x-axis only at a single point. So that's why this is known as simple root. But sometimes what happened, this function may be very highly non-linear and intersects the x-axis in multiple times. For example, here you will see that this function intersects the x-axis multiple times, and that's why this xi is repeated number of times, or maybe different roots, different places. So that's why we are having multiple roots. So when xi is repeated number of times, that means this curve intersects x-axis multiple time at the single place sorry, then the root is known as multiple root. Okay, so here xi at this point function is intersecting x-axis multiple times. That's why this is a multiple root. Fine. Now if we can write f of x is equal to 0 as x minus xi raised to the power m gx is equal to 0, because we are trying to find out the root. So obviously if xi is a root of this equation, then obviously x minus xi will be a factor, at least a factor. Okay, so you can easily write down f of x as this if xi is the root of this problem, where and gx is what? Gx is bounded and g xi is non-zero, because if g xi is 0, then obviously you can extract x minus xi again. So x minus xi is repeated number of times, still we are getting g xi is non-zero. So this means g xi is non-zero, and we have taken all the factors from this, and that's why all those factors are multiple times. So that's why x minus xi raised to the power m. That means we can say that xi is a root of this problem with multiplicity m. That means xi जो है वो एक root है और कितने बार repeat हुआ है? m number of times. So we have extracted all the factors, and now the final gx is this, which is obviously g of xi is non-zero. Otherwise again you can extract x minus xi from here, and then the multiplicity will be m plus 1. एक time और बढ़ जाएगी. So that's why. Okay. So here xi is called the multiple root of multiplicity m. In this case, if you will see, if you put f of xi here, then due to this factor, this will be 0. Okay. Similarly, if you take derivative, then its power will be m minus 1, and hence again you will see that when you put xi, then again you will get 0. So this will on and on. So that means first derivative of function f at point xi will be 0, second derivative at point xi is 0, and up to m minus 1. If you differentiate this function m minus 1 times and put xi, so again you are getting 0. But since its multiplicity of the root is m times, so when you differentiate this function mth time, then and put x is equal to xi, then you will see that its value will be non-zero. So using this concept, if you have evaluated xi is a root of this function, then with the help of this you can easily find out the multiplicity of the root. So just take the first, put xi is equal to x is equal to xi, so you will get 0. First derivative is 0, second derivative is 0, and m minus 1 derivative is 0. But you have seen, for example, in for any case, the mth derivative of the function at xi is non-zero, then obviously you can say that m is the multiplicity of the root, and you can write f of x as this form. Okay, so with the help of this equation you can easily find out the multiplicity of the root. Once you have evaluated the xi as a root or located as xi as a root, then to find out the m you can use this. Okay, now as far as the methods are concerned, methods to find out the roots of this problem may be explicit, may be implicit. So we have broadly divided the methods into two categories. One is the direct methods and another one is the iterative methods. Okay, now as far as the direct methods are concerned, they will give all the roots of f of x at a time. For example, Sridharacharya gives two roots at the same time for a quadratic equation. Okay, if your equation is quadratic, that means of order 2, then you can apply, or this form, then you can apply Sridharacharya and you will get two roots at the same time. यानी दोनों के दोनों रूट एक ही बार में आ जाते हैं. ठीक, so these type of methods are known as direct methods. But sometimes you are not getting you are not able to apply the direct methods. For example, this type of problem you are not able to write down the direct methods. Direct से आपको नहीं पता लगेगा कि root क्या है इसका. Then you can apply the iterative methods. What is the iterative methods? They will provide you root iteration by iteration. Okay, so give only one root at a time. That means इसमें आपके सारे रूट एक बार में आ जाते हैं, जबकि इसमें एक रूट एक बार में आता है. So give only one root at a time. Okay, at a time. And here these methods are further categorized into two types. One is bracketing methods, another one is non-bracketing methods. Bracketing means we are trying to basically find the roots in the, for example here, bracketing means what? This is the problem. For example, this is the root xi. Bracketing means we are trying to find the root in this interval, bracketed interval. Okay, so this is our interval where we are trying to find out the root. So these method works in a bracketing, in a bracket. Okay, and here we have two methods, bisection method and regular false method, regular falsy method. Now the second category is non-bracketing methods, यानी कोई ब्रैकेट नहीं है. That means open methods. इसमें क्या होता है? Here we have the same problem. Here we will try to find out, we will take this as the initial guess. This is the initial guess. Okay, we will take initial guess here, for example here, and we are moving in this direction openly. There is no left hand side here, or for example here we are trying to take initial guess as this point and we are trying to move here, and then there is no bracket here. So this type of problems where we have only one end, there is no second end, then those type of methods is known as open methods. And here we have three methods: secant method, Newton-Raphson method, fixed point or successive approximation method. Okay, so these are total 2 plus 3, 5 methods. So we will study these 5 methods in this unit. So these methods are based on the idea of successive approximations. Okay, so these basically the methods based on the idea of successive approximations, that is starting with one or more initial approximations to the root, we obtain a sequence of approximations or iterates denoted by sequence xk. Okay, here xk, which in limit converges to the root. यानी कि हम एक आइडिया, एक इनिशियल गेस से स्टार्ट करेंगे. फॉर एग्जाम्पल हियर we will start with here and slowly and denoted by say x1. Then we are trying to reach, this is x2, this is x say 5, for example x3, and slowly we will move to the xi. So we are getting a sequence of xk. Okay, and this basically sequence tends to xi, this. So this is the meaning. So we are getting a sequence. We will start with this initial guess, This is the initial guess. This is the initial guess, and then finally we will get a sequence x1, x2, xk and so on, and finally this sequence basically tending to xi. Okay, so this is the meaning. Now we will start with the direct method. We will give you some idea about the direct and iterative methods, which we have already discussed here. What is the meaning of direct and iterative methods broadly? Let's see. So here, if you will see, suppose we have a quadratic problem. Okay, we have taken quadratic problem because we know that in this category we have a method like Sridharacharya. So that's why we have compared the Sridharacharya with other iterative methods. So here we have taken a quadratic equation. Now the direct method. If you want to solve this problem, quadratic problem, a naught x square plus a1x plus a2 is equals to 0, where a naught is non-zero, then direct method is this: x is equals to minus a1 plus minus square root of a1 square minus 4 a naught a2 divided by 2 a naught. Because a naught is non-zero, so this is a valid quantity. So this is Sridharacharya. You have already aware about this method. So you can see that both the roots, when you are taking plus sign you will get one root, when you are taking minus sign you are getting second root. So both the roots came at a single time, यानी दोनों रूट एक ही बार में आ गए हैं. Okay, now as far as the iterative methods are concerned, let's see. So here we have taken three methods. Let's see how we got this equation. Let's see. Here we have this equation. If you will see, a naught x square plus a1x plus a2 is equals to 0. We have this equation. Okay, so how we can find out this? So what is our target? Our target is to write down this equation in this form: x is equals to some g of x. Convert this problem, which is originally of this form. हमारी इक्वेशन तो ये है, but we are trying to write down this equation in this form. Okay, and once we are getting this equation, then we will write down this in n plus 1 is equals to g of xn. Okay, in iterative form. This is the iterative form. So we have originally this equation. We will convert this problem into this form and then convert the problem in iterative form as this. So let's see how to apply this. First, how तो इसको इस फॉर्म में लिखने के there are various ways. You can write down this equation in this form in number of ways. For example, first way, just take, we can say that this x in the left hand side and remaining x, this term and this term in the right hand side. So what we will get? a1x is equals to minus a2 minus a naught x square, and then take this x in the left hand side. So x is equal to minus a2 minus a naught x square divided by a1. Okay, so from this equation we obtained this equation, and this is basically, what is this? This is your g of x, this. And now write down this iterative form. So xn plus 1 is equals to, replace this x as xn plus 1 and write down this x as xn. So minus a2 minus a naught xn whole square divided by a1. This is one iterative form method. Second, if you will take x from these two terms common, then what we will have? X a naught x plus a1, and take this a2 in the right hand side, so minus a2, and now divide this. So what we have? Minus a2 divided by a naught x plus a1. So now this is your g of x. This is your g of x. And now convert this into iterative form, this. So xn plus 1, that means this x is written as this, is equals to minus a2 divided by this a naught. This x is written as xn. So xn plus a1. This is another form. Okay, And now another is this. If you take this, retain this as in the left hand side, third one, here you take a naught x square in the left hand side and a1x in the minus a2 minus a1x. Okay, and now here x square, so this can be written as a naught x into x minus a2 minus a1x, and now take this x in the left hand side and this a naught x in the right hand side, so minus a2 minus a1x divided by a naught x. And now this is your g of x, so what will be the iteration formula? Minus a2 minus a1 xn divided by a naught xn. This is the formula. So we get three formulae from this equation, 1, 2, this 2 and the third one. So this is written here. This formula is xk plus 1 is this, second formula is this, and the third one is this. Okay, for the specific equation you may have multiple formulae, and remember कुछ फॉर्मूले इसमें कन्वर्ज करेंगे, कुछ नहीं करेंगे, बिकॉज वी नो दैट अ सीक्वेंस मे बी अ कन्वर्जिंग सीक्वेंस और मे बी अ डाइवर्जिंग सीक्वेंस. दैट्स वाई इसमें से कुछ फॉर्मूले कन्वर्ज भी करेंगे, कुछ डाइवर्ज भी करेंगे. ऐसा जरूरी नहीं कि इससे भी सेम रूट आ जाएगा, इससे भी आ जाएगा और इससे भी आ जाएगा. नो, दिस इज नॉट पॉसिबल. ओके, नाउ हियर k मीन्स 0 1 2 3. पुट k इज इक्वल टू 0 हियर. So we get x1 is equal to minus a2 plus a naught x1 whole square by a1. What is x naught? X naught is nothing but the initial gas. This initial gas. Okay. This initial gas is basically denoted by x naught. So initial gas आप रखेंगे कुछ idea and then we will get x1. फिर x1 को यहाँ रखेंगे x2. फिर x2 को यहाँ रखेंगे x3 and so on. So this is the procedure till we will get the required solution. Okay. So the convergence, so we are getting the sequence. अब ये sequence converge करता है कब, ये आपको पता है definition. So the convergence of the sequence xk to the number j, this depends on the rearrangement and the choice of the starting approximation x naught. मतलब आप कौन सा iteration formula ले रहे हैं. Rearrangement means whether you are opting first formula, second formula or third formula. Second thing is which is your initial idea x naught, because x naught is the initial idea near to the root होगा. So you, तो number of iterations आपकी घट जाएंगी. But if the initial idea is very far from the actual root j, then obviously number of iteration will be improved or increases. Okay, so these methods basically depends upon two things. One, your choice of the method, whether you are opting first one, second one or third one. Second thing, the initial idea x naught depends upon the x naught. Okay, so a sequence of iterates xk is said to be converged to the root j if limit k tending to j magnitude of xk minus j is 0. This is from the definition of the convergence of the sequence. You are already aware about this. So and in the limit form this can be written as limit k tending to infinite xk is equal to j. Okay, now here if xk minus 1, xk minus 2, xk minus m plus 1 are m approximations to the root, then a multi-point iteration method is defined as this. This is the multiple point method. Okay, so xk plus 1 is phi xk, xk minus 1, xk minus m plus 1. These are the m approximations. Then you can easily find out the next root. Okay, because these are the single point method, these are the multiple point methods. Okay, now for m is equal to 1, xk plus 1 is phi xk. Now here we have a problem. What is the problem? Here we have two major problems. One, how to select the suitable option. Second thing, how to find the initial approximation, because we know that these methods depends upon the rearrangement and the choice of the starting point. So these are the challenges. First, select the suitable option, and second is the initial idea. So as far as the second is concerned, initial idea. So solution of the second problem is that in general it is possible to find j which satisfies the given equation exactly. We therefore attempt to find the approximate root xi star such that either this magnitude of f x xi star is less than xi epsilon or magnitude of xk plus 1 minus xk is less than epsilon. इसका मतलब क्या हुआ? इसका मतलब हुआ कि जो हमें इनिशियल आइडिया निकालना है वो दो चीज़ें से निकाल सकते हैं, या जो फाइनल सॉल्यूशन आएगा xi स्टार वो दो चीज़ों, बिकॉज अगर आप लाते हैं इनिशियल आइडिया के बारे में जहाँ तक बात आती है उसके लिए आप इंटरमीडिएट वैल्यू थ्योरम आप लोगों ने रियल एनालिसिस में पढ़ी होगी, वो लगा सकते हैं. बट हाउ टू स्टॉप? सो टू स्टॉप द मेथड वी हैव दीज टू ऑप्शंस. वन, either your xi will satisfy this equation or your iterates will satisfy this equation. We will see these in later on so that you can easily understand the difference between these two. Okay, so here now to obtain the initial guess, here we have two methods. One is the graphical method, another one is the intermediate value theorem. Because our target is to find out the initial guess, initial choice x naught. How to find out this initial choice? So one way is graphical way, another one is intermediate value theorem. What is the graphical way? So you will see that here we have the problem f of x is equal to 0. So we have drawn the graph and initially we have taken that okay, this point is in between say 0.4 and 0.6. We don't know the exact value, but we know that this is in between 0.4 and 0.6. So that's why initial guess may be taken as say 0.45, maybe point nearby this 0.55 and so on. Okay, so this will give you some idea. Okay, second thing in graphical way, rather than writing this equation, because you have seen that here we have converted the problem, this converted into this problem. What is the meaning of this? If you will see, initially we have this problem f of x is equals to 0. That means the graph of this problem is this is the xi, but we have converted the problem as x is equal to g of x. And now what is the meaning of this? If you will draw the graph, then what is this? X is the linear equation. What is g of x? G of x is another say curve, say this type of curve. This is your g of x, this is your x, and they are equal. Equal means intersecting at this point. So this will also provide you the root. Here this point is xi, this point, this is xi, this is xi. So either you are taking this form or this form. If you are taking this form, then this will provide you the root. If you are taking this form, then they are intersecting at this point. So at the point where they are intersecting, the corresponding x is basically the root xi. Okay, so this is written here. For example, here this is the actual problem. So xi is the root and the function is say cos x minus x e raised to the power x. We have taken this example, we have drawn the curve. So this is the idea. But if you are writing this problem in this form, so this is the in this form. So here we have written this. Left hand side is x, y is equal to x, and another one is e raised to the power minus x cos x, because ये हमारा था. ठीक है, तो इसको हम कैसे लिख सकते थे? What is our target? Our target is to write down this x e raised to the power minus x is equal to 0. तो इसको हम ऐसे लिख सकते थे x e raised to the power minus x is equal to cos x, and then here x is equal to, this is plus x, this is plus x, so this will be plus x, so this will be e raised to the power minus x cos x. Okay, so what is the here? This is your y of x, this curve is e raised to the power minus x cos x, and they are intersecting at this point, so this will be the root. So this root and this root both are same. Okay, so this is the alternate way. Now the second, use of intermediate value theorem. So if f of x is continuous function on some interval ab, closed interval ab, and f of a into f of b is less than 0, then the equation f of x has at least one real root or an odd number of real roots in the interval AB. So this is the intermediate value theorem का ये इसका statement है कि अगर ये function continuous है and having opposite sign in between this interval, opposite sign means f of a into f of b is negative, then this equation has at least one real root or odd number of real roots in the interval open interval AB. This is the graphical way of this theorem. If this is the curve, this is continuous function, you will see here the value of the function is negative, here the value of the function is positive. So you will see that this curve intersects the x-axis at the point, single point, and this is the multiple points, here the negative value, here the positive value. So if you will see that this curve intersect the x-axis 3 times, 1 2 and 3. So that's why odd number of times. जैसे ही आप इसको इवन करना चाहेंगे ये फंक्शन फिर यहाँ आ जाएगा, तब f of a और f of b का साइन सेम हो जाएगा, बट हियर द कंडीशन इज अपोजिट साइन. दैट्स वाई ये इंटरसेक्शन जो करेगा ये हमेशा ही ऑड नंबर ऑफ प्लेसेस पे करेगा. ओके, सो दिस इज द आइडिया. So here we have, so this is the way, and we have taken the interval, but we are not trying to solve this problem here at this place. We will try to solve this method later on. Okay, so I think for the time being this is over. In the next video we will start the bisection method. Okay, so okay, thank you.